Hey, fourth grade, welcome back. I'm really excited because we're starting chapter 3 of our unit today. I'm really excited. I'm going to show you a simulation. It's going to be really dope. But before we get into that, we have another email that just came in, which I will read from you from the superintendent of the National Marine Sanctuaries. So, to us, the marine biologists, from Maya Martinez, superintendent. I recently met with another team of scientists who study dolphin communication. They reported some important observations from Stellwagen Bank. They observed that when a mother dolphin and her calf are separated, the mother whistles and her calf swims toward her. The scientists also observed that when a mother dolphin whistles, only her own calf swims to her. Now, I would like to investigate the following question. How does a dolphin calf know which call is his mother's call? Please provide an explanation to answer this question after you investigate further. Thank you. Okay, so that's the question we're going to be trying to figure out throughout this chapter. And a way that we're going to try to figure this out is a more general question, which is, how can we tell one sound from another? Because if we're thinking about it, we can think of one sound like a fire alarm in the school, right? Has a different sound than a fire truck's engine sound, right? Or an ambulance siren sound is different from what we would hear in like the school when a fire alarm goes off and we're exiting the building. Those sounds are different. They have different meanings, right? So how can we tell one sound from another? And that's going to help us go back to that question of how can a mother calf and a baby calf, a mother dolphin and a baby dolphin, a calf, how can they distinguish those sounds from one another? So the way that we can do this that's going to help us is some work that we did earlier in the week on Tuesday. On Tuesday, your exit ticket question had like 4 different sounds. I want to zoom in on this snake sound as well as the instrument sound. Now, we had to distinguish between whether the sound was high or whether the sound was low. So when we were here, we realized that this is a high sound because of the way that the wavelengths are. They are very closer together. They're higher up than the other ones. So if we look here for this instrument, we know that's probably going to have a low sound just because of the wavelength here is very long and drawn out. So that information that we did on Tuesday is going to help us with our information that we're trying to learn today. So keep that in the back of your mind of when you were working on Tuesday of how you were able to distinguish between a high sound or a low sound. And if you were having trouble with that, I gave feedback on how you can distinguish that. So let's keep that in our brain as we go on to today's. So before we get started, here's a think, pair, share. If you can say this out loud to yourself, you can go find a family member and pause this. But the question is, why do dolphin calves only respond to the whistles of their mothers and not to the whistles of other dolphins? So think about it. What's your first idea? What are you thinking about? So you can pause me right now, go talk to your family member, and go tell them, what do you think? Okay, welcome back. So what I'm thinking is, it's kind of like you with your parents, right? So if you're in a store with your parents and your parents calls your name, you're going to respond to them, right? Like different from if another random adult is calling your name, you're going to respond to your parents' voice because you are more familiar with it, right? So there's a possibility that that has something to do with it, because I know that my parents, or I'll go in particular, my mom has her voice sounds different than other moms. Just like when you hear your teacher, when you're in the schoolyard or you're lining up, you hear your teacher, you respond to their voice like, hey, I'm going this way because I hear Miss Clarke or Miss Lodge or Miss Lagan. I hear their voice. I know where I'm supposed to be right now, right? Compared to hearing another teacher's voice calling their class to go into their classroom. So keep that in your mind to help us try to figure out and answer this question of how we can figure out this dolphin calf, how they only answer to their dolphin mother whistle. So we have 2 new vocabulary words that we're learning today. So you can pause me right now so you can take a second to write these down because you already know they're going to be part of extra effort today. So the word amplitude means how tall a wave is, while the word waveform is the curved line that shows the pattern of a wave. So we're going to go into this and it's going to make a lot more sense once you see it in the simulation, but make sure you get this down, pause it if you need to, and then we're going to move on. So we're actually going to be working in a sound wave simulation today. And it's the same simulation that you were working with scientist Renee last week or the other day. But it's going to be a little bit different of where we're going inside the simulation. So you can either go into Clever and follow along and do it yourself, or you can also just continue to pay attention to the video, and I'm going to do it here. So let's see. Let's exit through here. I'm on Clever. I'm going to amplify, regular amplify, not amplify reading, because we're in science. Regular amplify. Going to wave energy and information. Going to number 1. Okay. So right now, this is what we were looking at last time. We're not going to do this time. We're going to be in the custom sounds. Change it to custom sounds. Notice that our green wavelength is on as well as our volume. I'm going to move myself over here. I'm also going to put my volume down a little bit because this can get really loud. And I know you guys are really sensitive to the sound, but just bear with it. It's super quick. So notice what's happening right now while there's no sounds. The wavelength is just a straight line. There's no movement. The particles are just moving around a little bit. So if we change, we're not going to change the wavelength. We're only going to change the amplitude. So if we change it to a small or in between small and medium, and we start to play, it's very low. And you can even see down here, it's just barely moving as it goes around and then it's done. Now, if it goes to medium and then we press play, it's getting a little bit louder and our waves are getting a little bit bigger as well. So I'm thinking in my head, okay, well, I'm making that amplitude go a little bit bigger each time. I bet when I go larger, it's also going to change a little bit too. So let's see. It might be a little loud. I'm not sure. Exactly. So with that, we can see that when it went from the smallest amplitude, it had a little bit of a wave, right? And it wasn't super loud. But as we changed the amplitude to go to medium to go to a large amplitude, the wavelengths got bigger and the sounds got smaller. I'm sorry. So the waves got bigger as well as the sounds. The sounds got louder as well. So now that we just saw that, I want to pay attention to what's happening with these particles as I change just the amplitude. Notice I did not change the wavelength from what it was. I'm only changing the amplitude. So I have it as a small amplitude and I'm going to press play. I'm actually going to highlight one of these particles and follow it and to see what it does. So right now there's no sounds. It's barely, it's just transferring some energy, but it's moving at like a regular pace. So if I do a small amplitude and I press play, notice you can barely hear the sound. And that same particle is just slowly bouncing as it hears that sound. We can even make it go a little bit bigger, like in between the small and medium. Still small though, close to the small. It's a little bit louder. That that particle is just still buzzing. Oh, it went away. It went behind our thing, so we can click this one over here. Yeah, it went behind our printout. But yes, it went just a very small. So for this one, we'll click this one. We'll go to medium. Let's pay attention. Oh, it looks like that while those waves are getting bigger, the sound is getting louder, is hitting and transferring more energy and hitting more particles. Okay, let's see large. Okay, we know it's going to be a little bit louder. Oh, as soon as the wave hit it, it's going and hitting those particles all very quickly, and is moving very fast. It's hitting and transferring energy very, very quickly. So let's go back to our PowerPoint. So we now know, I'm actually going to add a new slide. I'm going to add some notes now because we just did our notes from Sim. We saw that the amplitude was larger when the sound is louder. The amplitude was smaller when the sound is quieter. And the larger the amplitude, the more the particles moved and transferred energy. My bad. And then I noticed that when we have a sound, at different amplitudes, we have different volumes. So when we have a smaller amplitude, remember, amplitude means how tall the wave is. So when we have a smaller amplitude, we have a softer sound that comes from that wave. While then when we add a little bit more amplitude or a little bit more height to our sound wave, it gets a little bit louder. And then when it's at a large amplitude, it has a very loud sound that goes along with that. And then we know the larger the amplitude, the more those particles are moving, and they're more like they're going a lot faster and they're moving a lot more. So let's take a look. So we took these notes. If you need to go back and you need to pause this to get these down, go ahead, add them after your vocabulary. And here, and we just did this. We were just talking about this, that the amplitude is blank when the sound is louder. The amplitude is larger when the sound is louder. The amplitude is blank when the sound is quieter. The amplitude is smaller when the sound is quieter. So we know this. We had these in our notes now, and we had that information from our simulation today. And then we talked about in our notes what happens to the waveforms when you change the amplitude. If you need to go back here are the different changes and what happens with the different amplitudes. Now, if you want to draw, I want you to start, you can label it waveform for a loud sound and then a waveform for a quiet sound in your notes. And I'll give you a second to you can pause this real quick so you can draw your loud sound wave and your quiet sound wave. And if you need some help, this is the waveform for a large sound. That has a high amplitude, while a quiet sound is the amplitude is not as high. while we have a very high amplitude here, this amplitude inside the sound wave is very small compared to these very high. This has a very high amplitude. Now, when you're working today, you're going to be analyzing these 3 printouts. The printouts were on the bottom of our simulation. Now you're going to look at 3 different ones in your Google form. You're going to label them whether it's a loud one, medium, or quiet. And you will tell me, it will be a drop-down menu, and you will say which one it is looking at this. And this will show your understanding of our simulation and our understanding of what that word amplitude means, and understanding it when we're looking at the sound waves printouts. Okay, so we did a lot of great learning today. I'm so proud of you guys. I'm excited to see your work. And with that, when just this last reminder, when sound waves have different amplitudes, we hear these different sounds with different volumes. Just like when we hear our parents or our teachers calling us, they all have different voices and they all sound different, and they have those different volumes, and you're able to understand them and know that they are talking to you, right? So maybe that's some type of understanding of what's happening with that baby dolphin calf. There is some ways to earn some extra effort. I mentioned that earlier. There is a way to earn some Beyond Z as well. You can see that down below. And yeah, great job today. I cannot wait to, see your work, and then see if you do your Beyond Z and extra effort. Okay, guys, till next time.